As you begin your training, the first things you'll become familiar with are the components of the airplane and how to use the different controls to make the airplane respond. In this lesson, you'll explore the following topics: types of construction, airplane components, and aircraft documents. Throughout the 20th century, manufacturers improved aircraft durability and safety by implementing advancements in construction techniques and material technology. This increased durability and safety resulted in a large number of older aircraft staying in service even after decades of use. Early aircraft were built up from an internal airframe, typically of wood or steel tubing, which was then covered to give it a smooth surface. The covering materials varied. Some builders used sheet metal, while others used plywood. In all of these designs, one idea remained constant: using load-bearing airframes with separate skins. Until the late 1950s, fabrics were used for aircraft fuselage, wings, and control surface coverings. The fabric was glued, sewn, or laced to the wood or metal airframe, soaked with water to shrink the skin and remove wrinkles, and then doped to further tighten, seal, and protect it. As manufacturing techniques advanced, thin aluminum alloy sheets were used because they provide a lightweight and reasonably durable structure. Manufacturers can form these sheets into compound curves that enable them to create complex shapes that require little maintenance. Today, composite materials are quickly becoming recognized as the most advanced substance for fabrication of aircraft parts. The term composite describes two or more materials combined to form a structure that is much stronger than the individual components. The two most commonly used composite materials are glass fiber reinforced plastic and carbon fiber reinforced plastic. One of the first things you're likely to notice during a visit to your local airport is the wide variety of aircraft styles and designs. At first glance, you might think that aircraft look quite different from one another. But on closer inspection, you'll notice that there's a major component that training airplanes have in common: the fuselage. The fuselage is the body of the airplane. It houses the cockpit and cabin, which contains seats for the occupants and the controls for the airplane. In addition, the fuselage also provides room for cargo and attachment points for the other major airplane components. Although somewhat uncommon today, most early aircraft used an open truss structure. You can identify aircraft with open truss construction by the clearly visible struts and wire-braced wings. Advancements in technology enabled aircraft designers to enclose the truss members, which streamlined the aircraft and improved performance. Most modern airplanes use two forms of this stressed skin structure, known as monocoque or semi-monocoque construction. The monocoque design uses the skin to support almost all imposed loads. The structure can be very strong, but cannot tolerate any dents or deformation of the surface. This characteristic is easily demonstrated by a thin aluminum beverage can. You can exert a large force to the ends of the can without causing any damage. However, if the side of the can is dented only slightly, it collapses easily. Due to limitations of the monocoque design, many manufacturers use a semi-monocoque structure. The semi-monocoque system incorporates a substructure riveted to the airplane skin to maintain the shape of the airframe and increase its strength. The wings are airfoils attached to each side of the fuselage. These airfoils generate lift, the force that supports the airplane in flight. The number of wings varies. Airplanes with a single set of wings are referred to as monoplanes, and those with two sets are called biplanes. In general, there are two wings on the airplane, one attached on either side of the fuselage. The front of each wing is known as the leading edge, and the backside is the trailing edge. Two types of control surfaces are attached to the trailing edge of each wing: the flaps and the ailerons. Flaps extend outward from the fuselage to approximately the midpoint of each wing. The flaps are normally flush with the wing's surface during cruising flight. When extending, the flaps move simultaneously downward to increase the lifting force of the wing for takeoffs and landings. Ailerons control the bank of the airplane. The ailerons are attached to the outboard trailing edge of each wing and move in the opposite direction from each other. There are two main types of wing design: the cantilever and the semi-cantilever. The cantilever wing design contains no external bracing. Internal wing spars, ribs, stringers, and the skin of the wing carry most of the stress. The semi-cantilever wing design uses externally attached struts to brace the wings in addition to internal spars and ribs. Because of this external bracing, semi-cantilever wing spars can weigh less than cantilever wing spars. The tail of the airplane is known as the empennage. The empennage consists of the vertical stabilizer, or fin, and the horizontal stabilizer. These two surfaces act like the feathers on an arrow. They steady the airplane and help it maintain a straight path through the air. The rudder is attached to the back of the vertical stabilizer and can be used to move the nose of the airplane left or right, much like a rudder turns a ship. You operate the rudder with your feet, using pedals located in the cockpit. When you press the left rudder pedal, connecting cables move the rudder to the left, which causes the airplane nose to move to the left. Pressing the right pedal moves the rudder and the nose to the right. The last component of the empennage is the elevator. The elevator is attached to the back of the horizontal stabilizer. During flight, you use the control stick to move the elevator, which moves the airplane's nose up and down. Some airplanes have small hinged trim devices attached to the trailing edge of one or more of the control surfaces. Setting these trim devices minimizes your workload because they maintain the necessary control surface positioning for the desired flight attitude. When properly adjusted, trim devices lessen the resistance you feel on the flight controls. One such device commonly used on many training airplanes is called a trim tab. It's controlled by a wheel or an electrical switch in the cockpit. An airplane's landing gear absorbs the landing loads and supports the aircraft on the ground. The most common type of landing gear on training airplanes has 3 wheels. It consists of 2 main wheels located on the fuselage and a third wheel positioned either at the front or rear of the airplane. When the third wheel is located on the nose, it's called a nose wheel, and the landing gear is referred to as tricycle gear. Nose wheels can be either steerable or freewheeling. Most other airplanes are equipped with conventional landing gear, which consists of 2 main wheels forward and a tail wheel. This type is often referred to as a tail dragger. Landing gear is classified as either fixed or retractable. Fixed landing gear is always extended, but retractable landing gear can be raised after takeoff and stowed within the airplane structure for cruising flight. The wheels of an airplane are attached to the fuselage by struts that can absorb some of the shock of landing and taxiing over rough ground. Airplane brakes are located on the main wheels and are applied by using foot pedals in the cockpit. Foot pedals operate independently and allow differential braking, so you can apply varying degrees of braking to each wheel. During ground operations, depending on the type of airplane, you use either nose wheel or differential braking or both to steer the airplane. Most airplanes also have a hand-operated parking brake that holds pressure on both brakes to keep the airplane from rolling when your feet are off the pedals. Now that you have the pieces, you just need power. That's where the power plant comes in. The power plant is located in front of the fuselage and includes the engine, cowling, firewall, and propeller. The engine supplies the power that turns the propeller. The airplane accessories mounted on or connected to the engine generate electrical power to operate lights, instruments, and communication equipment, create a vacuum source for some flight instruments, and provide a source of heat for the pilot and passengers and for defrosting the windshield. The cowling, sometimes called the nacelle, streamlines the nose of the airplane, helps cool the engine by ducting air around the cylinders, and allows access to the engine and accessories. The firewall separates the engine compartment from the rest of the airplane structure. It's a fire-resistant bulkhead that protects the occupants from an engine compartment fire, and also serves as a mounting point for the engine. The propeller, sometimes called the prop, translates the rotating force of the engine into the forces that create the thrust to pull the airplane through the air. Although the number of blades on a propeller can vary, most training aircraft have 2 or 3. The Federal Aviation Regulations, or FARs, require that aircraft always have specific documents on board during aircraft operation. The first document is the Airworthiness Certificate. This certificate establishes that an FAA inspector has determined that the airplane met design standards at the time of its manufacture. It must be displayed at the cabin or cockpit entrance so that passengers and crew can read it. The next document is the Registration Certificate. This certificate is similar to your automotive registration in that it shows legal registration of the aircraft. The final required documents are these 2 parts of the Pilot's Operating Handbook, or POH, for that aircraft: the operating limits and the weight and balance records sections. To remember what documentation is required on board, use the memory aid ARROW, which stands for Airworthiness Certificate, Registration Certificate, Radio Certificate, but is only required for international flights, operating limits, and weight and balance records. Information about your particular make and model of airplane can be found in the Pilot's Operating Handbook, or POH. The standardized format and content of the POH make it easier for you to use and allow for easier transitions between different makes and models of aircraft. The POH is made up of 10 sections. Click each tab for a full description of each section. The General section contains basic information such as loading, handling, and pre-flight of the airplane. It also includes definitions, abbreviations, symbology, and terminology explanations. The Limitations section is supplemented by instrument markings and placards. It includes operating limitations, instrument markings, color coding, and basic placards necessary for the safe operation of the airplane. The Emergency Procedures section contains emergency checklists and expanded procedures for coping with various types of emergencies or critical situations. Related recommended airspeeds are also included. The manufacturer may include an Abnormal Procedures section that contains recommendations for handling equipment malfunctions or other abnormalities that are not of an emergency nature. The Normal Procedures section contains checklists and amplified procedures for conducting normal operations, including recommended airspeeds. The Performance section gives performance information appropriate to the airplane and presents it in the most likely order for use in flight. The Weight and Balance section includes weighing procedures, weight and balance records, computation instructions, and the equipment list. The Airplane and Systems Description section is a detailed explanation of the airplane and its systems in whatever format the manufacturer considers to be most informative. The Handling, Service, and Maintenance section includes information on airplane inspection periods, preventative maintenance that can be performed by the pilot, ground handling procedures, and servicing, cleaning, and care instructions. The Supplements section contains information necessary to safely and efficiently operate the airplane's various optional systems and equipment. Manufacturers have the option of including a 10th section on safety tips, as well as an alphabetical index at the end of the POH. The FAA required all aircraft built after March 1, 1979, to be equipped with an FAA-approved Airplane Flight Manual, or AFM. Like the POH, the AFM is specifically assigned to the individual airplane and must be accessible by the pilot during all flight operations. To satisfy the regulatory requirement, the POH for most aircraft is also designated as the AFM. Since the POH or the AFM normally stays with the airplane and therefore isn't available for you to review for extended periods of time, many manufacturers also publish a Pilot's Information Manual, or PIM. The PIM contains the same information as the POH or AFM, except for precise weight and balance data and optional equipment specific to a particular airplane. However, it is organized in the same manner as the POH and the AFM and is a useful study tool. Keep in mind that the PIM is not updated like your POH or AFM. In this lesson, you explored the following topics: types of construction, airplane components, and aircraft documents.